Okay, meanwhile, let me introduce myself. I'm Lavanya N. I'm a PhD research scholar at IIT Madras in the Department of Biotechnology. I work in the protein biophysics lab under the guidance of Dr. Adi Narayanan. So, throughout this course, for all of the 12 weeks, I'll be doing a live interaction session every Friday between 6 to 7 p.m. So, I hope you will continue to join and enjoy this experience. So this is my first time as a TA for this particular course, Principles of Downstream Techniques in Bioprocess. So before I start, I'd like to get a feel of my audience, that is you people. So which stage are you all in? Are you doing your high school or BTech, MTech or PhD, MS? So you can use the chat box to tell me about it. Or you can also unmute. Balamukundan, Kritagya, Sriram, Urja Narang. Okay. How do I call you?
My name is Chelsea.
Chels.
Chelsea.
I can't hear you. Are you? You can type if you're unable to speak. Okay. Kritagya is from MSc Industrial Microbiology. Also Urja Narang. Chels is BSc Biotechnology, third year. Chelsea. Okay. I hope I'm pronouncing it right. All right then. So let's start. So let me go to the first slide. I could either go with full screen, but I won't be able to see you type in the chat. I want this to be as interactive as possible so that you can solve the questions along with me. So each week, what we are going to do is, so you all have a quiz, right, for at the end of each week's lectures. So we are going to solve similar problems or questions that are related to the lectures that you listen to. So we're not going to cover anything out of it. It'll probably be a little application of what you listen to. So it'll mostly be closely associated with your actual quiz one assignment or quiz two according to each week. So in case you have any questions, doubts, or you need more clarifications, you can always stop me and ask. And I will also be closely following the Ask a Question portal in your MOOC portal where you have the course. You also have an option to ask a question. So, in case your doubts go unresolved, you can always approach me because this is a live session and I'm available at your service. Right? So, let's start. This is the first live interaction session for Principles of Downstream Techniques in Bioprocess. So today we are going to be covering the introduction to DSP, downstream bioprocessing techniques, and mass balance, heat balance, and flow sheet. Not so much of heat balance. And costing also was discussed by Dr. Mukesh Toli. So we'll be looking into some questions there. So going into first question immediately, why does the fermentation broth in alcohol production have ethanol concentration not more than 15%? So I'll give you 2 minutes. So think about the answer before we look into what the answer is. Okay, ethanol is difficult to synthesize. It is hard to metabolize. Ethanol at higher concentration kills the producing bacteria. It gets diluted in the extracellular broth. So you have four options. Sriram is doing MTech in food engineering and technology. That's great. So most of you are either in the penultimate years of or the final years of your BTech or in MTech. That's great. I hope nobody's wanting entry. You can type in the option in chat. I don't see any answers there. There's just 5 of you. And please don't take this as some a session where you have to just listen to me talking. So we are going to sit and solve questions together. And I'm just a student like you all. So yeah, go ahead and type in A, B, C, or D. Usually I used to have polls in activities in Google Meet if you're aware. But this time we don't have access to that. So maybe if you show in more interest, we can use a link to do an online poll with radio buttons where you just click them. Okay, so are you unable to get the question, or is it tough, or is it too easy or silly? It would really help if you can type in an answer. Okay, let's look into the answer. Before that, let's see how we can eliminate the other question. So the primary reason why alcohol cannot be synthesized beyond a particular concentration is because it becomes toxic to the producing bacteria themselves. So that is why it is always limiting to 10 to 15% concentration in the broth. And then you will have to take it to other kinds of distillation units or concentration processes to bring it to a concentration of higher percentage, say 20 to 30 or 40 or 95 or even 100% in case of analytical requirements in labs. For sterilization purposes, you need higher concentration of pure ethanol, right? That's why at the production state, you cannot go beyond 15%. That's for the most tolerant bacteria, right? Next, inoculum preparation is a downstream process, mixed process, upstream process, or a recovery process. So before you answer this question, I want to ask all five, six of you, have you gone through the lectures for this week? There were 3 lectures. So did you go through them? Okay, thank you, Chelsea. Yes. What about Sriram Balamurugan? I'm sorry, Balamukundan, Kritagya Gagoi? Yes, Kritagya has responded yes. Great. So you're all aware what an inoculum is, right? So at any point, if you don't know, thank you, Chelsea, you have to tell me. All right. Otherwise, I'll be expecting answers without knowing whether you understand and then don't answer, or you're unable to understand the question in the first place, right? Okay. It's unfortunate that I have to screen record. So I guess you're able to see your own answers. Is that what is preventing you from answering? Okay. So what is inoculum preparation? So in a fermentation process, you're going to add some seed culture, right? You're going to add some inoculum, which is then going to grow and produce your necessary metabolite or do some kind of biotransformation or synthesize some recombinant molecules that has been inserted into it as a gene. So inoculum preparation is not a downstream process. It's not mixed either, and it's just not a recovery process. It is indeed an upstream process. Question 3. Which downstream process is used to remove solids from slurry? Is it extraction, sedimentation, drying, or adsorption? Remove solids from slurry. Slurry can be the broth that is at the end of a fermentation process or a biotransformation process. All the contents within the reactor can be considered the slurry. And if you want to remove the solids from the slurry, what should you do? Great. Thank you, Shriram. Thank you, Kritagya. So the answer is sedimentation. Of course, extraction and absorption will be to concentrate or specifically take out certain components of the slurry, and drying is absolutely not the answer. So therefore, it is sedimentation. Thank you, Chelsea. Great. Question 4. Antibiotic production requires higher purity because pure antibiotics can be sold at a higher price. It is consumed by humans and needs FDA approval. Impure antibiotics become unstable over time. None of the above. Okay. I know all the options can seem a little, maybe this is right. So think about it. Which is the most appropriate or accurate answer? Why do antibiotics need to be extremely pure, as pure as possible? Is it about the price? Uh, I think Dr. Doble would have mentioned that downstream processing, especially for antibiotic production, takes almost as much as 30% or 40% of the cost. So, going through a series of steps or maybe chromatographic purification to achieve that 95 to 99% is very tedious. If I'm able to sell something at 40% purity for a lower price, I would go for it because it is going to reduce a large amount of my production costs. So it's not really about the price, although nobody is going to want to buy an impure batch of antibiotics. Why? Because you don't want to risk lives. We are dealing with human lives here. So it is consumed by humans and needs FDA approval or Indian equivalent of it. So that is the main reason. And impure antibiotics become unstable over time. Possible, but we don't know for sure. And uh, more than instability, we don't want any other chemicals entering your body whose effect you don't know about, right? So the reason is it is consumed, it is taken up inside your body, so you need to be very careful about its purity, right? Okay, so now we enter the numericals part for this week. I hope you all went through the quiz 1 assignment. So the following numericals are going to be very similar to what you have in the present week. So if you pay attention or clarify any doubts that you might have in solving these, you can as well go ahead and finish the assignment and submit, right? So let's look into this question. 3 downstream purification steps are used to recover 10 kgs of a product. So you can go get a calculator if you want, get a piece of paper, pen. So we'll give you 3 to 4 minutes to solve this. So 3 downstream purification steps are used to recover 10 kgs of a product. The efficiency of the product recovery in each step is 95, 97, and 93% respectively. What is the overall product loss in kgs? take 2 minutes. I'll wait. You can go ahead and solve it. I'm just depicting the question for my own reference when I solve it next. As soon as you're done, you can type in the answers in the chat box so that we know you're done, and I know you're done, and then we can go ahead with answering. If there is some difficulty in understanding this process or this question, or you want me to explain step by step how we should take this, you should let me know. Okay. Okay. Thanks, Urja. So, three downstream purification steps are used to recover 10 kgs of a product. So, right now you're out of the fermenter. Okay. I've given almost the same figure for everything, but just imagine this is the fermenter and you have 10 kgs of product that's ready. Now this is going to go through downstream processing. So it is going to go through, say, another distillation unit or some sedimentation unit, condensation unit, and then it is going to go through another separator. Okay, so it is going to go through 3 steps, and each step you're able to recover only 95, 97, and 93%. All right, so at first step the recovery is 95%. So what does that mean? I'm able to recover only 95% of this 10 kg. And what is that? 0.95 into 10, which is 9.5 kgs. So after stage 1, at this point here, I have only 9.5 kgs at hand, while I started with 10 kgs of product before step 1. Got it? 10 kgs of product are going to be recovered in 3 steps. So after step 1, I have 9.5 kgs, which is 95% of 10 kg. At step 2, so let me draw a line between these two. That was my initial diagram. This is what I'm explaining now. Okay. Yeah. At step 2, you're getting only 97% efficiency or recovery. 97% recovery from this 9.5 kgs and not 10 kgs. So what are you going to do? You're going to multiply 97 by 100 or 0.97 into 9.5 kgs. Got it? So what is that going to be? So I'm going to use my calculator. 0.997 into 9.5. So at stage 2, I'm going to have 9.215 kg of product. And at stage 3, again I'm going to multiply this with 0.93, which gives the answer as 8.56995. I'm going to approximate this as 8.57 kg. Did you get this? All of you understood what just transpired here? Great. So if we were to do this question again, so I'm starting with 10 kgs and I'm going through 3 processes, 95%, 97% and 93% in series. So the best way to do is I will start with 10 into 0.95 into 0.97 into 0.93. Instead of doing each process separately and breaking your head, you can directly go with 10 into point. I mean, it's over the watermark. If you're able to see it, I'm fine with it. I don't have to write again. So just check it out. 10 into 0.95 into 0.97 into 0.93. So again, the answer is 8.57 kg, right? So don't bother doing each step and multiply, so you might miss some decimals there, right? So just multiply whatever processes you have, the percentage in the product recovery in percentage. Don't forget the decimal here. So what is the overall product loss? So this is not your answer. This is your final product that you get. What is the loss in kgs? So what will you do? 10 minus 8.57 kg. What is that? I think it's 1.43, is it? 10 minus 8.57, just to be sure. Yes. So 1.43 kgs. That is your answer. Clear? Shall we proceed to the next question? I won't go ahead until you give me the green signal. Great. So what about what? Okay, great. Question 6. Two liquid feeds A and B at 15 and 25 liters per hour flow rate with at liters per hour flow rate with 3 grams of liter and 1.5 grams of liter tetracycline respectively are entering a centrifugal separator. The stream A leaving the separator now contains 0.7 grams of tetracycline. What will be the concentration of tetracycline in stream B leaving the separator? Again, if you need help, let me know so that we can immediately start discussing and not waste time waiting. What about Bala Mukundan? Are you comfortable with what's going on? Again, I'm just drawing stuff while I hope you're working out the problem. In case you have difficulty, let me know. Do you need help? Shall I start explaining? Okay, Kritagya. Let's call this C1 dash, and C2 dash is what? Okay, so you have a centrifugal separator, right? And you have two different streams, A and B. So you have, it can be in the same direction. I just wanted to separate these so you can have a clear view of what's going on. So A and B are mixing in this centrifugal separator, and then they're going their own ways after separation as A and B streams. So initially this has 3 gram per liter of tetracycline, and later it is having 0.7 gram per liter of tetracycline, whereas the liquid feed B has 1.5 gram per liter of tetracycline. What will be the concentration of tetracycline in stream B leaving the separator? So this is your question. What is C2 dash? And you have F1 here, and there's no mention of F1 and F2 in the outstream, in the output streams, right? We are going to assume that the system is in equilibrium or steady state, where at time well after the mixing has happened or the initial filling of the centrifugal separator has happened, the flow rates are going to remain the same. I'm sorry, I wrote F2 here, right? So 15 liters per hour is going to remain the same in stream A, and 25 liters per hour is going to remain in stream B. So how would you balance this? Look at it this way. These are the inputs and you have the outputs here. So how would you term this? F1 C1 plus F2 C2 is equal to F1 C1 dash plus F2 C2 dash. Am I right in saying that? Are you all with me? So the concentration into flow rate plus concentration found in B into its flow rate is going to give you the sum of, we are not looking at individuals here. So the tetracycline in stream A and B has redistributed. So when the stream A is coming out, it is having less tetracycline than it had before. So what does that mean? Stream B is going to have more, because whatever tetracycline was in stream A has now transferred to stream B in this separation process. Correct? So as a sum, when there is no accumulation within the tank or within the separator, it has to come out. Whatever is input has come, should come out in the output, right? So if I fill the components in each, what is F1? I'm going to do away with the units for now. We can add it in later. 15 liters per hour into 3 grams per liter. That is C1, right? 15 into 3 plus 25 into 1.5 equals, what is F1? 15 into zero point 0.7 plus F2 is 25 into X. So you just have one variable, right? I'm just referring to C2 dash as X. So I'm going to switch to the next slide where I have more space. 15 into 3 plus 25 into 1.5. Am I right? Yes, is equal to 15 into zero point 0.7 plus 25x. So solving for this, what do you have? 45 plus, what is this? 25 plus 12.5 is 37.5, right? Is equal to, what is 15 into 0.7? 10.5 plus 25x. So what does that give me? 25x is equal to 45 plus 37.5 minus 10.5, that is 72, and x is 72 by 25, which is 2.88 grams per liter, right? So we haven't changed the values anywhere. So at the output stream, A is having zero point 0.7 gram per liter of tetracycline, whereas B has 2.88 gram per liter. So did you not understand any of these steps? Please let me know. We can address that and proceed to the next question. Was this clear? Thank you, Shriram. Yeah, clear? Shall we proceed to question 7? Okay. In the manufacture of human insulin, 50% of the manufacturing cost is raw materials, and the rest is waste disposal, manpower, energy, and QC. Manpower contributes 25% of this remaining. Waste disposal, energy, and QC contribute equally to this remaining. What is the cost of QC in the overall manufacturing cost in percentage? We have moved to costing now. Take 2 minutes. This is a relatively easy question, so I'll wait for you to answer before I answer. Is it hard? So let's take this as the 100%. So is anybody working out? Do you want me to wait or shall I proceed? Yeah, sure, Chelsea. So in the manufacture of human insulin, 50% of the manufacturing cost is raw materials. So right there, 50% is gone, right? So this goes into raw materials. And the rest is this is raw materials, which is 50%. The rest is waste disposal, manpower. So let's write waste disposal, manpower, energy, and quality control. Four things contribute. The rest is these four things. So manpower contributes 25%. That is half of the rest 50, right? So manpower contributes 25% of this rest. So you have what? 50 and 25. That leaves very little space for the rest of the components. Waste disposal 1, energy 2, and quality control contribute equally to this remaining, which is this part, right? If I were to divide these three equally, we would have waste disposal, energy, and quality control, right? So what is the cost of QC in the overall manufacturing cost in percentage? So what is this component in this whole, this slice in the whole pie, right? This particular region. So how would you calculate that? Do you want to attempt now? Now that I've explained what you should calculate. Okay, let me go ahead. Since we have limited time, so I'll just go ahead. So 75% is already taken by raw materials as well as manpower. By using total cost is equal to sum of all costs. Yes. Since they're asking in percentage, and we also know everything by percentage only. We don't know how much it's going to be. Is it 70 lakhs, 80 lakhs, or 5 lakhs? We don't know. Right? Whatever the total amount is, 50% is taken by raw materials, 25 by manpower. So what is left? 25. And three people are sharing. I mean, three quantities are sharing. In disposal, energy, and quality control contribute equally. So 25 divided by 3. So each quality control, energy, and waste disposal take 25 by 3. What is that? 8 3s are 24. So it's going to be 8.33%. Say in 100 in the whole, right? So is that the answer? Is it acceptable to all? Okay. So you got it right. So the contribution by each of these guys is 8.33, 8.33, 8.33. And their question is just about QC. So you just answer it is 8.33. That's it. Yeah, we say 8.33. Next, a filter costs 30 lakhs and its annual depreciation is 5%. What will be its depreciated value after 5 years? Do you want to take a minute? Yeah, actually, take a minute and think about it. Maybe some of you listen to the lectures and you're already, I mean, aware of how to solve this problem. So we will take exactly 1 minute to calculate what the answer is and type in the chat box. If I get no answers, I'll proceed. Okay. Time's up. Anybody got the answer? Okay, so I'll go ahead and explain. Is that fine? So in cases of depreciation questions where you do not have any mention of resale value or yeah, what you're going to do with it, and when we are generally looking at a depreciation rate and the number of years, you can go ahead and use the compound interest formula. So what do you do with compound interest? I have a picture here, I think, right? So take FV as the future value. So how do you generally do compound interest? You do the principal into 1 plus r by 100 whole power n, right? But here the rate is going to be negative because it is depreciation and not it is not compounding. The interest is not compounding. On the contrary, you are having a negative value to your this thing. 1 second. Let me take these guys and go to the next slide. Yeah. So let's solve it now. So you want to know the future value of this product where you're going to multiply 30 lakhs into 1, and since it is negative, minus r by 100 whole power. How many number of years we have? 5 years. So that is equivalent to, let's solve just this part. What does this mean? 1 minus 0.05 power 5, which is equal to 0.95 power 5 into PV, right? So what does this give us? 0.95 raised to the power 5 into 30, 0, 0, 0, 6 zeros, right? So we have it as 23 lakhs 21,342.813. That's relevant to us. So yeah, if they ask you in lakhs, you would say something around 23 lakhs. Right? Was this clear? Do you want me to solve again? So this is 30. Okay. Excuse me. So Chelsea, each year you're going to have a 5% depreciation. So what does that mean? What is worth 30 lakhs today is not going to be worth 30 lakhs the next year. So let's just look at 1 year at a time. So next year, what is it going to be? It's going to be 5% less. So what does that mean? My filter is going to be only 95% its worth. Correct? Until then, are you okay with this? So today, if I have something, if I buy a filter of 100 rupees and its depreciating value is 5%, next year it is going to be worth 95 rupees. Correct? So here we are having 95% of present value, which is nothing but present value into 1 minus your depreciation rate. Or if you have R in percentage, it directly means 0.05. So 1 minus 0.05 into your present value. Got it? Because you're talking about a decrease here, depreciation. Only if you're talking about appreciation, it's going to be positive. If something is going to have more value next year, it is appreciation. So when you talk about investing in property or real estate, you ask about what is the appreciation? How much will I gain in a few years down the line? Because it is going to grow. Or suppose, assuming you are going to invest in a good place where the value of the land or the property grows. You are not going to invest in something that is going to depreciate over years, right? When you buy things like, say, cars or vehicles or machines, right, it is going to lose its value. It's not going to be as good as new. So each year it is going to reduce in value. So that is why we have a negative sign here. If it falls by 5%, it means it is falling from the whole, which is 1 minus that percentage. And this is for the first year. If I do it for the next year, like how we did the previous time, in this particular thing, you're going to multiply again with 0.95, which is nothing but 1 minus r, right? For the next year, you're going to multiply with another 1 minus r. So for each year, you're going to multiply in that particular value, not with the present final value. So each year when you compound, what does that mean? Present value into 1 minus r, where r is in percentage. Otherwise, you have to put it by 100. Got it? R by 100. I have it the easy way. R by 100 whole power n, where n is the number of years. That's how you get this formula. Is that clear, Chelsea? Thank you. So what was the answer that we had here? Let me write it again. 23 lakhs 21,342.8. Okay. Shall we move to the next question? I am inheriting a cash. I hope all the others also understood the previous problem. Okay, we are going ahead. If anything, do let me know. I'm inheriting a cash of rupees 170 lakhs in the year 2025. What will be its net present value in the year 2022, assuming discount rate as 10%? Do you want me to solve it, or are you in the process of solving it? Hello, Ishita. We're a little late, but thanks for joining us. So I'm inheriting a cash. We are doing a problem now in the year 2025. So what will be its net present value in the year 2022? And number of years is 3. It's all right, Inshit Kaur. Sorry, I called you Ishita before. I'm sorry. in Shidkar. So we are going to have a session every Friday between 6 and 7 p.m. So it'll be really useful for you if you can avail this opportunity to bug me with doubts, questions, right? The rate is 10%. So remember that when you're inheriting some cash in future, so what is 100 rupees today? Maybe just uh, like how sir said, 100 rupees or say 100 rupees today is more worthy than 100 rupees in 2025, right? So even in that, if you had gone through the lectures in costing lecture, I guess, where you have the debate between centrifuge or a filter, which one to buy. So you see that all the maintenance costs are reduced when you're computing the cost and in today's value, right? So if you have to get 80,000 3 years later or 5 years later, the value today is going to be less than that. So if you invest this amount, it is going to return 80,000 in future in 3 years. So I can actually invest something less than say 77 or 78,000, and then after 3 years, I might be able to recover 80,000, right? So the net present value is going to be lesser than 170 lakhs. So be clear in that. So if you get an answer above 170 lakhs, you have made some mistake. That's what I'm trying to say here. And I hope you all remember the formula that you had there. You have to put the future value. Right, so I'm going to replace 170. What is the net present value? And R is 10%, which is zero point 0.1. So shall I answer, guys? Do you want to solve this? In N is 3. I've literally spoon fed. What is the answer? Are you all clear with the logic? I did not copy paste this formula since it was already there in the lecture. Hello, Sanjana. Were you all misinformed about this session? It's actually between 6 and 7 p.m. Okay. Sriram has given us an answer. That's right, Sriram. Thank you very much. So is everybody okay with the logic here? The discount rate is 10%. So you're going to add 1 plus zero point 0.1. So 1.1 cube. 170 divided by 1.1 for 3 years. Or you can also take it as net present value into 1.1 whole cube gives you 170 lakhs in 3 years in 2025, right? So the answer is 127.72 lakhs. Clear? Okay, so the last and final question for this round. A fermentation broth contains 20 weight percent. I would rather like it 20% weight of dead mass and rest liquid. The latter needs to be recovered fully. The annual production of the broth is 20,000 kgs. A filter press retains 12%, 12.8% of the liquid in the solid waste, while if a centrifuge is used, the solid retains 1.58% of the liquid. How much liquid is lost if I use filter press as compared to the centrifuge? So take 2 minutes, think about it. I'm going to draw the schematic so that it's easy for us to solve when I work out this problem. We're going to look into two scenarios here, right? One is where you have the filter press, and the other where you have centrifuge. This is the filter press. So fermentation broth contains 20% as dead mass and the rest is liquid. So let's take this fermenter. This is 80%, this is 20%. So 20% we are not interested, and this is what we are going to remove. 80% liquid, the latter needs to be recovered fully. So this is our most interesting part. The annual production of the broth is 20,000 kgs. So put together, this is 20,000 kgs. So 80% into 20,000 kgs. First find this. Okay. Yes. So if you're, I hope you're all working this out. So first figure out what this is, followed by what this is, and then this, and compare these three quantities and tell me which one's better. Or I mean, obviously we know which one's better. How much liquid is lost if you use filter press as compared to centrifuge? Take a minute. We have already crossed time. Okay, so I don't see any answers. Let me proceed. So what is zero point 0.8 into 20,000 kgs? So that is 60,000, 16,000 kgs. So 80% of the fermentation broth is 16,000 kgs, which is the liquid part and which we want to recover. So the filter press contains 12% of the liquid in solid waste. So when it is filtering, so if you have a filter membrane like this, it is going to collect all the solids here and the liquid is going to flow out. But between this solid, it is going to retain 12% of the liquid. So what is that? 0.12 into 16,000, which is 1920 kgs. And for 1.5%, what is that? 0.015, correct? Into 16,000. What is that? 240 kgs. So how much liquid is lost if I use filter press as compared to centrifuge? So if you go ahead and use filter press instead of centrifuge, you lose how much? 1920 minus 240. 1680 kgs. Am I right? Did you get a different answer? Can I repeat again for filter press and centrifuge? Sure, Sriram. So, do you want me to take a fresh page? Are you clear with this? So, we had the fermentation broth. I mean, it's not strictly a division here, but we are assuming the solids will settle, and so this is 20% is solid and 80% is liquid. Now, this is going to go through either filtration or centrifugation. So, in a filtration unit, say you have the filter here, it is having multiple pores. Sorry, let me take a different color. So, I'm having a membranous filter here, and I'm pouring the entire fermentation broth. So, what will happen? The solid material, whatever is there, is going to settle above the filter, and the liquid is going to percolate through. But you know, this the broth kind of settles. There's no active. You even if you press, there is going to be some liquid sticking into the between the wet solid, right? There will be spaces inside the solid particles. You cannot completely press it. There will be some resistance because that also has some mass, and the membrane will also not let it go. Some of the liquid is going to get entrained here, and that is 12%. In centrifugation, nothing. You're going to centrifuge it, so the at high speeds the solid mass is going to settle very close to each other, and you're able to minimize the liquid entrained within the solid mass. All right. So only 1.5% of the liquid gets entrained or trapped within this solid mass in a centrifugal filter. I mean centrifuge, sorry, in centrifugal separation. But in filtration, you're losing 12% as liquid, which is trapped within the solid mass that requires to be removed. So what does that mean? The entire total volume is 20,000, of which liquid is 80%, and you can take it as 16,000 kgs is liquid. And here 12% of it is trapped, 12% is 1920 kgs. So 12% you should not do it with 20,000. You have to do 0.12 into 16,000. Correct? That is 1920 kg. And here you're going to lose 1.5%. So what is that? 0.015 into 16 kgs. Because the rest 4 kgs anyways you want to lose that solid waste. You don't want to carry this to your final processes. 4 kgs you want it out of your how to say the future steps where you concentrate the product of interest. So 16 kgs is your goal. 16 kgs is what you're interested about, and that's all your concern is. So 12% of 16 kgs is lost here, and 1.5% of 16 kgs is lost here, which is 420. What was it? 240 kgs. And the difference between these two is 1000. Oops. Okay, I somehow lost that. 240 kg. And the difference between these two amounts is 1006. Oh, now I got everything. God, some glitch in my. Yeah. Okay, I'm unable to edit that. So the difference between these two is 192. What was it? 1680, is it? Okay. All right, something's wrong. Yeah, 1680. Thank you, Shira. Yeah, that's it. I don't know why I'm unable to edit this out though. Okay, we'll see that later. All right, you guys understood? Do we multiply zero point 0.8 with 1/6 because only liquid needs to be required? Correct, Chelsea. We multiply zero point 0.8 with 20,000, not 16,000. We multiply zero point 0.8 with 20,000 because the latter needs to be. Okay, I'm unable to use my pencil. The latter needs to be recovered fully, not the former. So, which is the former here contains 20% of dead mass. You don't want the dead mass. And rest liquid. So, liquid is the latter guy. So, 80% is liquid. And the latter needs to be recovered fully. So 80% of these liquid, 80% of the fermentation broth, which is the liquid, needs to be recovered completely. So 16,000 kgs is our interest, is what we worry about. Okay, of which 12% gets trapped in solid dead weight, dead mass in case of filtration, and 1.5 gets trapped in case of centrifugation. And so you multiply 0.015 with 16, 0.12 with 16, and you get the difference here. Oh, I'm still unable to edit this out. Something's wrong. Okay. Yeah, but you got the gist right. It's 1680 kgs. Clear? Everybody is okay with this? So with that, my presentation for today ends. So I'll be looking forward to see you all in the next session next Friday, 6 to 7 p.m. I hope this was useful. Thank you all. Have a great weekend. Are condensers a part of the downstream process? Yes. You can also post your doubts in ask a question page. We'll address it, and you can anytime ask me during the live sessions. Okay, guys. I'm going to log out. Thank you very much.